I'm here now with Jeffrey Kordower. He's from Rush University, a professor of neurological sciences. Thanks for joining me.
My pleasure.
Okay, you have done a lot of research into Parkinson's disease, but now you're looking into the tau tangles. You are one who's in the so-called tau tangles camp. Tell me a little bit about your research with tau and why you believe that tau may unlock a lot of the mystery around Alzheimer's.
Well, so I still do a lot of work in Parkinson's disease, and I think that many, if not all, degenerative diseases are what we call prion-like, and they are due to proteins that are normally found in the brain and misfold for some reason. And then once they misfold, they're able to spread from one place to another, causing other cells to misfold. And we believe that that's what's involved with disease progression. We know in Alzheimer's disease that disease probably starts in the brain at a region sort of on the lower side of the brain called the entorhinal cortex. And so we think that, and that area is filled with neurofibrillary tangles. And if you take someone who's got very early Alzheimer's disease, but still has memory and cognitive deficits, that's the area that has the most degeneration. And that's the area that has the most neurofibrillary tangles.
But hasn't science been working on the presumption that the plaques come first, followed by the tangles?
We now have the ability to clear these plaques, but still when you clear these plaques, nothing happens in terms of the patient clinically. You could say that maybe they've already done their damage and there's nothing to protect, but I think that the correlation between plaque load and cognitive dysfunction is very poor, and the correlation of tau pathology is much better, and actually the correlation of what we call synaptology, where the neurons project to a different area and they connect. Those connections are probably the most that correlate with cognitive dysfunction. So that's what we're trying to get at with tau.
To what extent can we isolate how much damage has been caused post-mortem in a brain, plaques versus tangles?
Yeah, so you only get one snapshot in a post-mortem brain. And so what you have to do is look at a lot of different brains that have a spread of cognitive dysfunction in the patient population that were generous enough to donate these brains. So now what you do is you look at patients who just have mild Alzheimer's disease and patients who have severe Alzheimer's disease and a scattering of brains in the middle. And then you look at tangle load versus amyloid load. And what you find is that the tau load is much more correlative with the cognitive dysfunction.
If tau is indeed confirmed to be a source of the damage of an Alzheimer's brain, how does that change things, and which direction would research go in order to, what does it look like to prevent tau tangles?
Well, what you can do is, there are a number of approaches. The most popular one that's emerging is called immunotherapy, to use antibodies to try and block the spread of what we call seeds. So what you have is a cell that makes abnormal tau, and that tau secretes into the extracellular space, the space between cells, a seed of abnormal tau that is now picked up by a second cell, and that second cell starts generating more and more abnormal tau, and then it secretes a little seed. And so the same thing happens over and over again. And if you can block this seeding from one cell to another, what we call propagation, you should be able to block the degeneration that's taking place over long periods of time, and you should be able to prevent the onslaught of cognitive demise.
Okay, so we know that there are some tau drugs being tested right now. They're in clinical 3 trials. Where are we in knowing whether or not your philosophy or the philosophy that a lot of the tau camp is betting on is right?
Well, when tau misfolds, normally it would not misfold because there are organelles or parts of a cell that clear unwanted protein. So it's sort of like your garbage disposal. You put something in, you grind it up, and it goes away. But what happens is with tau and other misfolded proteins like alpha-synuclein, that these garbage disposals in the cell stop working, and you get more and more and more of the tau built up. So there are a number of ways to try and reduce tau and prevent that from happening. Some of these drugs may be trying to enhance the ability for the garbage disposal to work better. And I'm not sure of the timelines that are ongoing at the moment with these tau drugs, but phase 3 clinical trials is basically the step before going into therapies. So we're hopeful that they'll be successful.
Is there anything that we've learned from diseases such as Parkinson's that could help us with Alzheimer's disease?
So the idea that misfolded proteins propagate came originally from Parkinson's disease. And this protein called alpha-synuclein, which is normally found at the connection point between two cells, becomes misfolded and again does this song and dance with these seeds to go across and propagate across the entire brain. And so people thought from there, maybe tau, maybe amyloid also can propagate from cell to cell. So these are very active areas of research.
Great. Thanks very much, Evan.
You're welcome.